Our fourth machine learning technique in the series is the random forest model. Random forest consists of hundreds or more decision trees, with each tree using a random subset of data. All of the decision trees cast a vote on the classification of a sample, and the majority vote wins. So when does the experimental design use it? The answer is often. The random forest is one of the most commonly used models. It's used when, one, there's a lot of variables to consider, such as the expression of thousands of proteins. Two, you only have moderate computing capabilities. Three, you don't want to analyze a separate set of samples for cross-validation. Four, the groups are or are not normally distributed. You can use both types of data sets. Now on to our example experiment. We analyzed the protein profile of 1,000 proteins of 100 healthy patients and 100 cancer patients using an antibody-based microarray. We want to find biomarkers that will predict which future patients are healthy or diseased. How does it work? First, create a table where each row represents a protein and each column represents a patient. Then, assign groups. Here, you tell the software which samples are healthy and which have cancer. And this is your a priori knowledge. Then, center the data by subtracting the mean of each patient dataset from itself. Now all datasets have a mean of 0. Scale the data by dividing each patient dataset with its standard deviation. Now, all datasets have a standard deviation of 1. Set aside 1/3 of the data. These samples will be used in step 7 for cross-validation. Next, create our decision trees using a subset of samples and variables at a time. The modeler determines the number of trees. Each tree will be created using a different random subset of data. The same sample can be chosen more than once to create one tree. Then, determine the accuracy of the random forest. The samples set aside in step 5 are tested against all of the decision trees. The accuracy of the random forest is the proportion of patients that are correctly identified by the random forest. That's called using a testing and training dataset. So what does the data look like when you present it? The random forest model is an ensemble of hundreds of trees that cannot be represented easily. However, the biomarkers used to create the model can be extracted during cross-validation and evaluation of the model's performance, for example, via the ROC curve analysis.